Good morning, everyone. Welcome to math. Let's jump in. Today, when we're done with this lesson, we'll hope that everyone can understand the difference between division grouping and division sharing. Let's just take 30 seconds to remember the difference between these two terms. Division grouping is a situation in which you know what the size of each group will be, but you don't know how many groups you can create. In sharing division, you know how many groups there are, but not how many will go in each group. Let's take an example from one of the previous assignments just to start putting our thoughts together about grouping and sharing. The swim team is going to a meet across town. There are 35 swimmers on the team, and each van can take 5 of them. How many vans will be needed to take the whole team? Well, here's the equation. 35 divided by 5 equals 7. That's true because 7 times 5 is 35. Let's break this down and decide what each number means in this situation. Our dividend 35 is our 35 swimmers. Divided by 5. Each of these is a group of 5 students getting into a van to go across town. So we know the size of each group. Each group is 5 students. The question is asking how many vans are needed. How many groups do we need to get them all there? Well, we need 7 groups of 5 to take all 35 students. So what does our answer tell us? It tells us the number of each groups. I need not white ink, but red ink. We already know the size of each group. The size of each group was 5. What we didn't know was how many groups we would need. We'll need 7 vans to get them all there. So this is a grouping division question. You might want to take a picture of this or copy it down, or if you copied it down from the last video lesson, have it on hand because we're going to be talking a lot about sharing and grouping today. And it can get confusing as to remember which is which. Let's remember that sharing answers how many will be in each group, and grouping answers how many groups there will be. So here's a couple of situations with some pretty easy division. Remember, we're not trying to challenge you with difficult division in these lessons. We're trying to understand what division is. And today we're going to throw another wrinkle in, because we're going to throw a fraction or two in towards the end and really start to see what dividing with fractions is all about. So here's this pretty easy division problem. 6 divided by 3 is, don't hurt yourselves, 2. Why? Because 2 times 3 equals 6. So here's 2 different situations about Max or Brianna and cookies. But are they in the right place? Is this a sharing problem, and is this a grouping problem? Well, I'm going to read them both and decide, and we'll talk a little bit about it. Max made 6 cookies. He gave them to his 3 sisters to share equally among themselves. How many cookies does each sister get? Well, in this situation, we have 6 cookies. We have 3 people sharing them. Doesn't this just sound like sharing division? 3 sisters sharing the cookies. So we know we have 3 groups, sister 1, sister 2, and sister 3. What we don't know is how many they will each get. And sharing answers how many will be in each group. So each sister will get 2 cookies. Is this a grouping problem? Brianna made 6 cookies. She put them in sacks of 3 to take to the neighbor's house. How many sacks was she able to fill? Okay, she still has, it's the same situation with 6 cookies, but she's not sharing them with people. She's putting them into bags, 3 in each bag. And the question is asking how many bags or sacks was she able to make? So how many groups can she make? Grouping answers how many groups there will be. So this is indeed a grouping problem. Let's move on to 6 divided by 2. 6 divided by 2 is 3. Because 2 times 3 is 6. Here's the two situations. I'm going to read them out loud, but I want you to decide if they're in the right place. I'm going to pause for about 5 seconds here. You can pause the video if you need longer, and you decide if they're in the right place or not, or do they need to be switched? You can pause here if you need more time, but I'm going to continue. Sally has 6 swimming trophies. She wants to display them on 2 shelves. How many can she place on each shelf? Is this a sharing problem? Well, do we know how many groups there will be? No, we don't. The question is asking how many can she place on each shelf. We do know how many groups there will be. There will be 2 groups, 2 shelves. What we don't know is how many will go on each shelf. So this question is answering how many trophies can go on each shelf, how many will be in each group. So this is a sharing problem. This does belong here. Sally wants to put her swimming medals in small frames. Each frame holds 2 medals. How many frames does she need to display all 6 medals? Is this a grouping problem? Let's see. Do we know how many groups there will be? No, we don't. We know that she's putting 2 in each group. In each frame, she's going to put 2 medals, but we don't know how many frames that she needs. She has 6 medals. 6 divided into groups of 2 would equal 3 groups. So this is a grouping problem. It does indeed answer how many groups there will be. So these two are in the right place. Let's move on to 6 divided by 1. Well, let's take a look. What is 6 divided by 1? 6 divided by 1 is 6, because 1 times 6 is 6. Let's see if these two are in the right place. Just for fun. Let's mix them up a little bit. Let's do this. Now, where will they land? Whoops, did not mean to do that. Are these in the right place? Yes or no? I'm going to, again, give you a chance. Let me just fix this. Give you a chance to read them and decide if they are in the right place. I'm going to count to 5 before I continue, but you can pause the video to give yourself a little more time if you need it. Okay, pause if you need more time. Noah has 6 graphic novels he has already read and wants to give them away to his friends. He has one friend, not friends, sorry about that. One friend who enjoys graphic novels. How many can he give that friend and be fair? Not tricky to think about. Mathematically, anyway. He has one friend. He's going to share 6 graphic novels with that one friend. The friend will get all 6. So in this situation, we know how many groups there are. What we didn't know was how many graphic novels that group would get. This is a sharing problem because it answers the question, how many in each group? Over here, Noah has 6 graphic novels and wants to keep them on a separate shelf from his other books in his room. If each shelf can hold 6 books, this should actually, to represent this problem, it should actually say if each shelf can hold 1 book, how many shelves does he need to hold these graphic novels? Sorry about that. Well, in this situation, we know that the groups hold 1 book each. These must be very small shelves. Maybe it's more like a little book stand. How many shelves does he need to hold these graphic novels? He'll need 6 of them, 1 per book. So in this situation, we did not know how many groups there would be. So this is a grouping problem. Here's another situation. Out of focus here for some reason. Hang on one second.